It's a new year. We're working on Algebra 2 this year, and we are starting on Lesson 1-1. And I'm so excited to be here to guide you through all this great math lessons for the year. We are going to look at real numbers and their graphs today. We're on Lesson 1-1, and our essential question is, do you understand real numbers, graphs, and absolute value? It is very important to understand which numbers are what. Number theory is very, very important. Natural numbers are also called counting numbers. I'll write that above. Whoops. Counting. And I like the word natural numbers because it's what naturally came out of your mouth when you learned how to count. So it's a set of the numbers of 1, 2, 3, 4, etc., etc., etc. Whole numbers are all natural numbers, but there's one number that's included, and that's the number 0. So notice that all natural numbers are whole numbers, but not all whole numbers are natural numbers. There's a perfect SAT question. We see questions like that all the time. Let's talk about integers. Integers are negative and positive whole numbers, meaning they can't have decimals or fractions. So notice this ... means that it keeps going. So notice the number 100 is an integer. The number 100 is a whole number. The number 100 is a natural number. All right. Rational numbers is when it gets fun. Rational numbers are in the form a over b, and I like to say that because they are decimals and fractions, because notice that 1/2 is equal to 0.5. But notice that 4 over 1, that's also equal to a rational number because we know that 4 over 1 is equal to 4. So they are negative and positive. So I'll put that positive and negative right here. And it's a result numbers such as -5/3, 0.5, 3 over 1 that result when an integer is divided by a non-zero. So notice this b is a non-zero integer. And last but not least, let's talk about irrational numbers. These are those numbers when you put into your calculator, you're going to get something that does not terminate and repeat. So let me go back to rational numbers. These terminate, which means they end, and they also repeat. Where irrational numbers don't terminate or repeat. And here are just some little rules of thumb. Each point on a number line is paired with exactly one real number. Now, a real number is all the numbers that we just talked about. Natural numbers, integers, rational, whole. This is called a coordinate. So you have probably heard of the word coordinate, but I'm going to go ahead and underline that because you do need to know what a coordinate is. Moving on, number 2. Each real number is paired with exactly one point on the line called the graph of the number. So we'll be talking about some of these things. All right, moving on to example 1. Find the coordinate of the point 2/3 of the way from A to B. So the first thing we have to do is notice where A is. Well, if this is 0, this is -1, this is -2, this is -3. And we're going all the way up to 6. So we have to know how many spaces that is. 1, 2, 3, 4, 5, 6, 7, 8, 9. Or I could know that this was 3 and this was 6, which is the absolute value. The absolute value is the distance a number is from 0. So if I have 9 units from A to B, I need to go ahead and take 2/3 of 9. Well, 2/3 multiplied by 9, I know 3 can go into 9 3 times, and 2 times 3 is 6. So what we're looking for is the 6th unit away from A. So here I have 1, 2, 3, 4, 5, 6. Where do you guys think that lands me? That's going to land on 3. So the answer to this question is 3 is the coordinate of the point 2/3 from A to B. All right, the next thing says graph the numbers negative 0.5 and negative 5 on a number line, then write an inequality statement. Well, the first thing you have to know is what is an inequality statement? If something is an inequality and not equal, it's going to be less than, greater than, less than or equal to, greater than or equal to. So these are inequality statements. All right, so since we're going all the way to our negatives, I'm going to call this 0. So this is negative 1, negative 2, negative 3, negative 4, negative 5, and it said to graph, which just means I'm going to put a dot at negative 5, and I'm going to put another dot at negative 0.5. I'm going to guesstimate is right there, and I'll go ahead and label this so you know. Great job. All right, every real number has an opposite. What are opposite numbers? Well, for example, the opposite of 3 is negative 3. The opposite of 5 is negative 5. Let's look at some more, hey, look at that, some more words. The opposite of 3 is negative 3. The opposite of negative 5 is 5. The opposite of 0 is 0, because remember, a negative times 0 or anything times 0 is going to be 0. All right, the last thing I'm going to talk about is this absolute value. If you need to know anything today, I would say get to know your absolute value. Absolute value is very important. The definition is the distance from 0. A lot of students tell me the definition is, oh, it's positive. That is true, because distance has to be positive. But absolute value is the distance from 0. So notice the absolute value of 5 is 5. The absolute value of negative 5 is also 5. But then I get questions when we have to solve. So, for example, what if I'm solving 3 times the absolute value of negative 6, like you see here? We are going to solve like PEMDAS, but I'm going to do absolute value because it's kind of like a parenthesis or a grouping. So 3 times, well, the absolute value of negative 6 is just positive 6 because it is the distance from 0. And 3 times 6 is 18. Let's look at example 7 here. The absolute value of negative 4 is 4. The absolute value of 6 is 6. And 4 plus 6 is 10.